Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the mean from a frequency table practice questions. If you need any extra help on finding the mean from a frequency table, you can watch the video tutorial on corbettmaths.com/contents, and it's video number 54. Alternatively, you could scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. So question number one. Question number one, we're told that Robbie played 20 football matches for his school team. So he's played 20 matches in total, and the number of goals that he scored in each game are shown in this table. So he scored no goals in 3 games, he scored 1 goal in 5 matches, he scored 2 goals in 9 games, he scored 3 goals in 1 match, and he scored 4 goals in 2 matches. And part A says, work out the total number of goals scored by Robbie. So we could do this by, we know there's 3 matches that he scored no goals, so we could do 0 plus 0 plus 0. We know there's 5 matches where he scored 1 goal, so we could do plus 1, plus 1, plus 1, plus 1, plus 1, and so on. But that would just take a bit of time, especially to write out those 20 numbers and add them all up. So we're going to work out this mean from the frequency table. So we're going to add on a column, let's call it fx, and we're going to multiply the frequency by the number of goals, x. So let's multiply these and see what we get. So in 3 games, he scored no goals. So he scored no goals altogether. And a quick way of getting that 0 is to do 0 times 3. 0 times 3 is equal to 0. In 5 matches, he scored 1 goal, so that'd be 5 goals. And again, a quick way of doing that is 5 times 1, and 5 times 1 is equal to 5. So in 9 matches, he scored 2 goals, so that would be 18 altogether, and 9 times 2 is 18. In 1 match, he scored 3 goals, so 1 times 3 is equal to 3. And in 2 matches, he scored 4 goals, so altogether that would be 8 goals in those 2 matches. And we've been asked to work out the total number of goals scored by Robbie, so we just need to add up this fx column, and that will tell us the total number of goals scored by Robbie. So we need to do 0 plus 5 plus 18 plus 3 plus 8. So let's do that and see what we get. So 0 plus 5 is equal to 5, plus 18 is equal to 23, plus 3 is equal to 26, plus 8 is equal to 34. So he scores 34 goals in total. So in part A, we were asked to work out the total number of goals scored by Robbie, so the answer is 34, so 34. And part B asks us to calculate the mean number of goals scored per game. So altogether, Robbie scored 34 goals, so the total is 34, and he played 20 matches. We were told he played 20 matches. And we can add up the number of matches and just check that's the case. So 3 plus 5 is 8, plus 9 is 17, plus 1 is 18, plus 2 is 20. So he played 20 matches altogether. So if we just divide the total number of goals by the total number of matches, we can then see the mean number of goals scored per game. So we need to do 34 divided by 20. Now this is a non-calculator question, so we could divide by 10, which is 3.4, and then half that to get 1.7. So we can divide by 10 and then divide by 2, or we could divide by 2, which is 17, and then divide by 10, which is 1.7. So that's one approach. Alternatively, we could use the bus shelter method, so we could do 34 divided by 20, and let's put a decimal point in a 0 because we know that it's not going to go in exactly. So 20 into 3, that's 0, remainder 3. How many 20s are in 34? That's 1, remainder 14. And how many 20s are in 140? That would be 7. So the answer would be 1.7. And remember, to find the mean, we divide the total by the number of numbers. In other words, we divide the total by the total frequency. So we've done 34 divided by 20. Okay, let's have a look at our next question. Okay, question number 2, and this is a calculator question. The table shows the number of sweets in 20 bags. So there's 20 bags altogether, and if we added up the frequency, you would find that's equal to 20 because 1 plus 4 is equal to 5, plus 9 is equal to 14, 17, 20. So there's 20 bags, and the table shows the number of sweets in each of those 20 bags. So 1 bag had 23 sweets, 4 bags had 24 sweets, 9 bags had 25 sweets in them, 3 bags each had 26 sweets in them, and 3 bags they each had 27 sweets in them. And we've been asked to calculate the mean. So that's the total, so that'll be the grand total number of sweets divided by how many bags there are, and that'll be the mean number of sweets in each bag. So we need to find how many sweets there are in total. So let's add on our fx column. We had 1 bag of 23, so 1 times 23 is equal to 23. We had 4 bags of 24, so 4 times 24. And this is a calculator question, so that's going to be equal to 96. We've got 9 times 25, so 9 times 25 is equal to 225. 3 bags of 26, well 3 times 26 is equal to 78, and 3 bags which each contain 27, 3 times 27 is equal to 81. So we've got our numbers in our fx column, so if we add those up, that would tell us how many sweets there are in total. So if we add those up, 23 plus 96 plus 225 plus 78 plus 81, that would tell us how many sweets there are in total. So 23 plus 96 plus 225 plus 78 plus 81 is equal to 503. So there's 503 sweets altogether in the 20 bags. So to find the mean, we're going to divide the total, which is the 503 sweets, by how many bags there were, which is 20. And that'll tell us the mean. In other words, the mean number of sweets in each bag. So if we do 503 divided by 20, that's equal to 25.15. That means that the mean number of sweets per bag was 25.15. And that's it. So our mean is 25.15. Okay, let's have a look at our next question. Okay, question number 3. Question number 3 says, Lily visits an arcade while on holiday in Weston-super-Mare, perhaps in the arcade at the end of the pier, and she plays 100 games and wins tickets that she can exchange for prizes. And the table below shows the results. So she plays 100 games. Sometimes she wins tickets, a lot of the time she does, and on some occasions she doesn't win any tickets. And we need to work out, so part A says, work out the total number of tickets won. So we need to find out how many tickets Lily won in total. So she played 2 games where she didn't win any tickets. So that's going to be in total 0, the FX column 0. She played 11 games where she won 1 ticket. Well, 11 times 1 will be 11 tickets altogether. She played 28 games where she won 2 tickets. So 28 times 2 would be equal to 56. She played 18 games where she each won 3 tickets in each game. So 18 times 3 is equal to 54. So she won 54 tickets there. She played 11 games. When each of those games she won 4 tickets. So 11 times 4 would be 44 tickets in total there. 15 times 5 would be equal to 75. 10 times 6 is equal to 60. 2 times 7 was equal to 14. And finally, she played 3 games where she won 8 tickets in each of those games. So 3 times 8 would be equal to 24 tickets. So this is the number of tickets that Lily's won. If we want to work out the total, we just need to add them up, and that will be the grand total. So let's add these up and see what we get. So 0 plus 11 plus 56 plus 54 plus 44 plus 75 plus 60 plus 14 plus 24 is equal to 338 tickets. So altogether, Lily wins 338 tickets. And then the question says, part A, work out the number of tickets won, the total number, 338 tickets. And part B, we're asked, what prize can she get with the 338 tickets? No, part B, we're asked, calculate the mean number of tickets won per game. So in other words, the mean number of tickets won in each game. So that's going to be the mean. So we're going to divide the total, the 338, by the number of games she played. And if we have a look at the question, she played 100 games. We're told she plays 100 games, but we could add up the frequencies if we wanted to. And if we added those up, we do get that's equal to 100. Let me just check. Yep, that's equal to 100. So we know she played 100 games. So if we divide the total number of tickets she won by the 100 games, we can then find out the mean number of tickets won per game. So 338 divided by 100 will be 3.38. So that means that Lily wins 3.38 tickets per game as her mean number of tickets won per game. Okay, and that's that. So let's have a look at our next question, question number 4. So question number 4 says 30 students were asked how many cats they owned, and the results are shown in the table. So we've got number of cats and number of children. So if we added up the number of children, that should be 30. 6 plus 13 is 19, plus 7 is 26, plus 3 is 29, plus 1 is 30. And the question says, calculate the mean number of cats owned per child. So we need to work out the mean number of cats owned per child. In other words, the mean from this frequency table. So let's work out the total number of cats and then divide it by the number of children, and that will give us the mean. So let's add our FX column to work out the total number of cats to begin with. So 6 children owned no cats. So 6 times 0 is 0. There's no cats. 13 children owned 1 cat each. So 13 times 1 would be 13. 7 children own 2 cats, so altogether that'd be 14. 3 children owned 3 cats, 3 times 3 is 9, that'd be 9 cats altogether. And 1 child owned 4 cats, so 1 times 4 is equal to 4. So if we want to work out the total number of cats, we need to add up this FX column to see the total number of cats. So 0 plus 13 plus 14, that's 27, plus 9 is 36, plus 4 is equal to 40. So altogether there's 40 cats. So we found that there's 40 cats altogether. Now the question says the mean number of cats owned per child. So we need to divide the total number of cats by the number of children to work out the mean number of cats owned per child. So let's add up the number of children, or in this case the frequency, which would be these numbers here. So we'll add up this column, the number of children, and we're told that's equal to 30. So that's equal to 30. So there's 30 children altogether. So to work out the mean number of cats owned per child, we need to divide the total number of cats, which is 40, by the number of children, which is 30, and that would tell us the mean number of cats owned per child. So 40 divided by 30 is equal to 1.3333 and so on. So it would be 1 1/3 or 1.333. I'm just going to write it as 1.33 to 2 decimal places Okay, and that's it. Okay, let's have a look at our next question. Question number 5. Okay, question number 5. So question number 5 says, a company collects data about the number of internet devices in each of 50 households. The table shows the results. So this table shows us the number of internet devices in 50 households. So there's 50 households altogether. If we add up the frequencies of the number of households, we get 50. And we're told in one household, there's no internet devices at all. In one household, there's one internet device. In 2 households, there's 2 in each of them, so that'd be 4 altogether. In 4 households, there's 3 internet devices, and so on. And the question says, work out the total number of internet devices in each of these 50 households. So if we add on the FX column and multiply the frequency, the number of households, by the number of devices in each of those households, we'll get our FX column, and then we can add that up to find the total number of internet devices. So in one household, there's no internet devices, so that's 0, or 1 times 0 is 0. In one household, there's 1 device, that's 1 altogether, 1 times 1 is 1. In 2 households, there's 2 devices in each of them, so 2 times 2 is equal to 4, so that'll be 4. 4 times 3 is equal to 12, 9 times 4 is equal to 36, 13 times 5 is equal to 65, 10 times 6 is equal to 60, 7 times 7 is equal to 49, and finally in 3 households there's 8 internet devices in each of those households. 3 times 8 would be 24 altogether in those 3 households. And we want to work out the total number of internet devices in these households. So if we add up this FX column, we will find the total number of internet devices. So 1 plus 4 plus 12 plus 36 plus 65 plus 60 plus 49 plus 24. And that's equal to 251. So there's 251 internet devices altogether in these 50 households. So 251. And our next part B, says calculate the mean number of internet devices per household. So we need to divide the total by the total frequency. So we need to divide the total number of internet devices, 251, by the total frequency, or the total number of households, which was 50, and that will tell us the mean. So 251 divided by 50 is equal to 5.02. So 5.02. So the mean number of internet devices per household is 5.02, and that's it. Okay, let's have a look at our next question. Question number 6. So Alex works for the council and he records the number of people in cars travelling down a street over 1 hour. So he's looking at these cars travelling down the street and he's writing down how many people are in each of the cars as it travels down the street. And here are their results. So we've got 41 cars with 1 person in each of those cars. We've got 54 cars with 2 people in each of those cars. We've got 32 cars with 3 people in each of those cars. We've got 20 cars with 4 people in each of those cars. And we've got 3 cars that have got 5 people in each of those cars. And part A says, work out the total number of cars that travel down the street. So in this question, if we look, it doesn't actually tell us how many cars travel down the street. So if we add up this column, the number of cars, that would tell us how many cars travel down the street in total. So 41 plus 54 plus 32 plus 20 plus 3 is equal to 150. So 150 cars travel down the street. Now, part B. Part B says work out, so that's 150. Part B says work out the total number of people that travelled in cars down the street. So we want to find out the total number of people that travelled down the street in cars. So we've got our FX column. And in each of these 41 cars, there's 1 person, so that'll be 41 people altogether. So 41, then 41 times 1. In each of these 54 cars, there's 2 people in each of them. So that means that 54 times 2 would be 108 people altogether. In 32 cars, there's 3 people in each of them. So 32 times 3 is equal to 96. In 20 cars, there's 4 people in each of them, so that's going to be 80. And in 3 cars, 3 times 5 would be 15 people altogether. And if we add that up, our FX column, that would tell us how many people there are altogether. And that's equal to 340. So part B says work out the total number of people that travelled in cars down the street. That would be 340. And finally, we're asked to work out the mean number of people travelling in each car. So there's 340 people altogether. We're going to divide that by the number of cars, which was 150. In other words, we're dividing the total FX by the total frequency. And whenever we do that, we get an answer of 340 divided by 150 is equal to 2.26666, and so on. Or let's round our answer to 3 decimal places. That would be 2.267 to 3 decimal places. To 3 decimal places. And that's it. So the mean number of people travelling in each car would be 2.267. And that's it. Okay, let's have a look at our next question. So question number 7. So question number 7 said, Mr. Edwards asked his class how long they spent revising for a test. So the table shows their results. So this is what they said. So this is how many hours of revision they said that they studied. So 1 student said they didn't do any hours of revision. 10 students said that they revised for 1 hour each. 7 students said they revised for 2 hours each. 3 students revised for 3 hours each. 1 student revised for 4 hours. And 3 students revised for 5 hours each. And Mr. Edwards says the average amount of time spent revising for the test was 1 hour. So 1 hour. Do you agree with him? Explain your answer. So Mr. Edwards says the average amount of time spent revising was 1 hour. Now he didn't specify whether it was the mean, the mode, the median. So let's work out the mean, the mode and the median and see if they are 1 hour and see if we agree with Mr. Edwards or not. So let's start with the mode. So the mode would be the modal amount of time spent revising. So we're going to look for the amount of time spent revising which happened the most often. So in other words, the one with the highest frequency. So as you can see here, 1 hour occurs 10 times. So that is the most common. If you wrote these down in a list, we would have 1 0, we'd have 10 ones, 7 twos and so on. So the mode would be 1 hour. So the mode is 1 hour. So Mr. Edwards is right in that regards, in terms of the average amount of time spent revising. Well, he was right for the mode is 1 hour. So let's now have a look at the mean and the median. So let's work out the mean. So to work out the mean from this frequency table, we're going to add on our fx column. And let's work out our mean. So 1 times 0 is equal to 0, 10 times 1 is equal to 10, 7 times 2 is equal to 14, 3 times 3 is equal to 9, 1 times 4 is equal to 4, and 3 times 5 is equal to 15. So if we add up this fx column, that would tell us the total number of hours the class said they revised for. So 10 plus 14 plus 9 plus 4 plus 15. And that's equal to 52 hours. So we now know the total number of hours spent revising, so the total fx, that's 52. We now just need to divide that by the total frequency, so how many students there were. And in the question, we're not told how many people are in the class, so let's add up the frequencies. So let's add up our frequencies and see how many students there are. That's 1 plus 10 plus 7 plus 3 plus 1 plus 3. So altogether there's 25 students. So if we do 52 divided by 25, that would tell us the mean. Because if we added up the total number of hours they spent revising, that's 52. And then there's 25 numbers in our list. There's 25 answers or 25 students. So if we divide 52 by 25, that will give us our mean. So 52 divided by 25 is equal to 2.08. So 2.08. So the mean's equal to 2.08 hours. Now, Mr. Edwards said the average amount of time spent revising was 1 hour. Now, our mean's actually double his claim, or actually more than double his claim. So I don't think his claim's right. I think his claim's much lower than actually how much time the class spent revising. Now, obviously, the mean can be affected by outliers. So let's find the median to see what the median amount of time spent revising was, just to make sure that we are confident that Mr. Edwards' claim is too low. So the median. So to find the median, it's the middle number. Now we could do this in two different ways here. We know there's 1, 0. One student said 0 hours. There's 10 students that said 1 hour. So we could do 1, 1, 1, 1, 1, 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7 students say 2 hours. So we could do 2, 2, 2, 2, 2, 2, 2, 1, 2, 3, 4, 5, 6, 7. Yeah. 3 students said 3 hours, so 1, 2, 3. 1 student said 4 hours, 4, and 3 students said 5 hours, so 5, 5, and 5. And we could then find the median by finding the middle number, and we could cross off the smallest, the biggest, the smallest, and the biggest, and so on. So crossing off the smallest and the biggest, the next smallest, and the next biggest, the next smallest, and the next biggest, the next smallest, and the next biggest, and so on until we find the median. And we've found the median is equal to 2. So the median is 2 hours. And that's one way of finding the median. I found that one quite time consuming using that approach. And our frequency was 25. What if that was 105? That would take quite a long time to write out 105 numbers and find the median. So there is a quicker way to do it for a frequency table like this. And if you've got a frequency table like this, so where we've got like our values, 0 hours, 1 hour, 2 hour, 3 hours, and so on. If there's 25 numbers, if you lined up 25 people all together, to find the position of the median number, to find the position of the median, you add 1 and divide by 2. So if we take our 25, we could do 25, add 1 is equal to 26. And if we do 26 divided by 2, that's equal to the 13th number. And if you think about it, if you had 5 people and we wanted to find the position of the median, if there's 5 people, we can take 5, add 1, which is equal to 6, and 6 divided by 2 is equal to 3. So the position of the median is the third person, 1, 2, 3. Okay, so here, because we were looking for the 13th person, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13th person, and we want to find out how much time they spent revising, a quick way to do it would have been to take the total frequency, 25, add 1, which is 26, and half it to be the 13th person. And then we can just look at our frequencies and find where the 13th person would be. So the first person who said 0 hours, they're not the 13th person. Then we've got another 10 people. So if we lined up these people, all 25 people, the first person's not them. We've then got the next 10 people. So that's 11 people so far. So the median, the 13th person's not in those first 11. Then we've got another 7 people. So if we've done 11, then we've got 12, 13. So the 13th person's in here. So the 13th person's in here, so that means they must have revised 2 hours. So the median would be 2. So that's another way to do it. So we could list out all the numbers if we wanted to, if the number's quite small for the total frequency. Or another way to do it is to take the frequency, add 1, and then divide by 2, and that will tell us the position of the median person. And that's for a frequency table like this, where we know the total number of hours: 0, 1, 2, 3, 4, 5, and so on. And if it's group data, we can deal with it slightly differently. Okay, so the question says, Mr. Edwards said the average amount of time spent revising was 1 hour. So the mode is 1 hour, that is the most common, but the mean is actually 2.08 hours, and the median is 2 hours. So do I agree with Mr. Edwards? I don't. I think Mr. Edwards' claim is actually much lower than what the average would be. I think the average would be more like 2 hours. So do I agree with him? No, I don't. The mean and the median were at least double his claim of 1 hour. I think Mr. Edwards was being a little bit harsh in this class. Okay, let's have a look at our next question. Question number 8. So question number 8 says, Chloe owns a restaurant. So Chloe owns a restaurant, and she surveys a group of people about how many times they've been to her restaurant. So she went up to this group of people and said, how many times have you visited my restaurant? How many times have you visited my restaurant? You need to visit more. No. Okay. And the highest number of visits to her restaurant was 5. So the highest number, whenever she asked all these people, whenever she asked them, how many times did you visit the restaurant? The highest number of visits, so somebody said it was 5 visits. Okay. And the table shows the information about her results. So whenever she asked this group of people, 41 people hadn't been to the restaurant, but we're awkward there. 38 people have been once. 15 people have been twice. We don't know how many people have been 3 times. 3 people have been 4 times, and 1 person has been to the restaurant 5 times. And then we're told the total number of visits to her restaurant by the group was 160. So the grand total number of visits to her restaurant by that group of people was 160. And we've been asked to find the missing frequency. So we want to find this missing number. Now don't add up these numbers and take them away from 160, because this frequency represents the number of people in the group. So she asked 41 people, they said no visits. 38 people said 1 visit, and so on. This 160 would be the total number of visits. In other words, if we added on our FX column, 41 times 0 is equal to 0. There's been no visits by those 41 people in total. There's 38 people that have been visited once, so 38 times 1 is equal to 38. There'd be 38 visits to the restaurant in total. Then 15 people visited twice each, so that'd be 30 visits for them. Then we've got our row with the missing number. We'll come back to that in a minute. Then we've got 3 people who have visited 4 times each, so that'll be 12 visits in total. And 1 person who visited 5 times, that's 5 visits in total. Now at this point, we've got 2 different approaches we could use. One approach is to not use algebra, and the second approach is to use algebra. And I'm going to actually do both of them, so just to show you. So first of all, one approach could be to add up our FX. So I had the total number of visits so far. So we can add up our 38 plus 30 plus 12 and plus 5. And plus 0 if you wanted to, but it's not going to change your answer. And whenever you add up those values, that's equal to 85 visits. So out of these people that we know, and when she asks these people so far, altogether there's been 85 visits to her restaurant, but we've been told there's 160 altogether. So we know whenever we add up this column, it's going to be equal to 160. So if we do 160, take away 85, that will tell us what number will go here. So whenever we do 160, take away 85, that's equal to 75. So the 75 visits here, so that means that there's going to be, whenever she's asked these people, and they've all visited 3 times each, the 75 visits in total. And we just need to figure out what this number would be. Remember, we've done 3 times this number to give 75. So 3 times 25 is 75, but doing 75 divided by 3 is equal to 25. So that means there must have been 25 people here. So she's asked 25 people, and they've each said 3 visits in total. And that means that if we go through our table, the 41 people who said no visits, the 38 people who visited once, the 15 people who visited twice each, the 25 people who visited 3 times each, and so on. And we went through all of those, that would be 160 visits. So the missing frequency is 25. So that's one approach. So we found 25 using our non-algebraic approach to begin with. Now let's have a look at the question using algebra. So let's go back to the point where we had our choice of approaches. So at this point, whenever we worked out our fx column, we know that the total frequency is equal to 160. Now at this point, we could have let our missing frequency be equal to y, or x, or whatever you want to call it. And to find this value in the fx column, we would do 3 times y. So 3 times y is 3y. So we've got our fx column, we've got 0, 38, 30, 3y, 12, and 5. And if we add these values up, that will be equal to 160. So let's add this column up and see what we get. So 0 plus 38 plus 30 plus 12 plus 5, adding up the numbers is 85, and then we've got our 3y, so that's going to be equal to 3y plus 85. If we add up this column, that gives us, if we add up the numbers, that's equal to 85, but we've also got our 3y, and remember in algebra you can't add the y terms and the numbers together, so our total f(x) column will be 3y plus 85. But we're told that's equal to 160. So if we write that as an equation, 3y plus 85 equals 160, we can solve this equation to find out what y is, and that's our missing frequency. So let's take away 85 and take away 85 from both sides of our equation. On our left hand side we'll get 3y, and on our right hand side we've got 160, take away 85, which is equal to 75. Now that's 3 times y, we don't want our times by 3, so we could divide by 3 and divide by 3, and y equals, and 75 divided by 3 is equal to 25. So again, our missing frequency is 25, and that's it. Okay, question number 9. So question number 9 says the table shows the amount of money being withdrawn from a cash machine. So we've got this cash machine, and 22 times was £10 withdrawn. On 15 occasions, £20 was withdrawn. On 3 occasions, £30 was withdrawn by the customers. 3 different customers withdrew £40, 5 times, on 5 occasions £50 was withdrawn, and on 2 occasions £100 was withdrawn. And part A says write down the modal amount of money withdrawn. So the modal is the one that happens the most, so the one with the highest frequency, so that would be £10. So £10 is the one that happens the most often. On 22 occasions £10 was withdrawn. Okay, part B. Part B says find the median amount of money withdrawn. Now I could write down 22 10s, 15 20s, 3 30s, 3 40s, 5 50s and 2 100s. I could write that down on a list, but I don't really fancy writing down those numbers all like that many times and finding the middle number. So what I'm going to do is I'm going to use our other approach. And if you look back in the video to question 7, I talked about that other approach. So let's talk about it again now, that other approach. So let's find out how many numbers there are altogether. So there's 22 plus 15 plus 3 plus 3 plus 5 plus 2. So working out the total frequency gives us 50 numbers. So if we were to write out our list, there'd be 50 numbers altogether. So we want to find the position of the median. So if you had 50 people and you want to find the position of the middle one, you would add 1. So 50 plus 1 is equal to 51. And then divide that by 2. 51 divided by 2 is equal to the 25th point fifth value. So if we had 50 people on a line and you wanted to find the position of the median, the middle person, it'd be in between the 25th and the 26th person. It'd be the 25th point fifth person. So now let's find the median. So let's find the 25th point fifth value in our list. So if we were to write these down in order, we'd have 22 10, so we'd write 10 10 10 10 10 22 times. Well, we're looking for the 25th point fifth one, so it's not going to be one of those values. Now we've got 15 20s. So after writing the 22 10s, we then have 15 20s. So we would have the 23rd value would be 20, the 24th value would be 20, the 25th value would be 20, the 26th value would be 20. So the 25th point fifth value will be in between 20 and 20, so it's going to be £20. So the median is in here, and the median would be £20. Okay, and part C says work out the mean amount of money withdrawn. So to work out the mean, let's add on our fx column. So 22 times 10, that would be £220 altogether. 15 times 20 would be £300. 3 times 30 would be £90. 3 times 40 would be £120. 5 times 50 would be £250. And 2 times 100 would be £200. And if we add up our fx column, that would tell us the total amount of money withdrawn from this cash machine. So 220 plus 300 plus 90 plus 120 plus 250 plus 200 is equal to £1,180. So to find the mean, we're going to divide the total fx by the total frequency. We're going to divide the total amount of money by how many times the money was taken out, and that would tell us the mean. So if we divide the total fx by the total frequency, so 1,180 divided by 50 will be the mean. And whenever we work that out, we get, and whenever we divide that, we get that's equal to 23.6. Now we are dealing with money, so it's going to be £23.60. So the mean amount of money withdrawn was £23.60. And that's it. Okay, let's have a look at our next question. Okay, question number 10. So question number 10 says, a French teacher asks her class of 20 students how to spell 10 words. So she's given them 10 spellings, and the table shows their results. So 1 student got 5 correct, 3 students got 6 correct, 5 students got 7 correct, 8 students got 8 each correct, 2 students got 9 each correct, and 1 student got 10 out of 10. And our question then says, work out the percentage of the class that scored greater than the mean number of correct answers. So we want to find out, first of all, we want to find out the percentage of the class that scored greater than the mean. So we really need to work out the mean to then work out how many students scored greater than that amount to then change that to a percentage. So let's find the mean. So let's add on our fx column, and to find the values in our fx column, we're going to multiply the frequency by the number of correct answers. So 1 times 5 is 5 correct spellings, 3 times 6 is another 18 correct spellings, 5 times 7 will be another 35 correct spellings, 8 times 8, 64, 2 times 9 is equal to 18, and 1 times 10 will be equal to 10. So if we add up the fx column, that would tell us the total number of correct spellings by her class. So 5 plus 18 plus 35 plus 64 plus 18 plus 10 is equal to 150. So altogether there were 150 correct spellings in the class. Now we want to find the mean, so we're going to want to divide this, the total of the fx column, by the total frequency. Now we're told in the question there's 20 students, and we can just check this. 1 plus 3 is 4, plus 5 is 9, plus 8 is 17, plus 2 is 19, plus 1 is 20. So there's 20 students altogether. So to find the mean, we're going to take our 150 and divide it by 20, and that will be the mean. Now this is an on-calculator question, so if we do 150 divided by 2, that's 75. So if we do 150 divided by 20, that would be 7.5. So the mean is 7.5, so that's the mean. And the question says, work out the percentage of the class that scored greater than the mean number of correct answers. So we're looking for the percentage of the class that scored greater than 7.5. So if we look at our class, there's 20 students altogether. 1 student scored 5 correct answers. Well, they're not going to be greater than the mean. 3 students scored 6 correct answers. They're not greater than the mean. 5 students scored 7. Well, it's 7.5, so they scored lower than the mean. Now, these 8 students scored 8 marks, correct? So they scored greater than the mean. The mean's 7.5. They've scored 8, so these 8 are above the mean. These 2 students scored 9 each. They're above the mean. And this 1 student got a 10 out of 10. Well, they're obviously above the mean. So altogether, how many students scored greater than the mean? So it's going to be 8 plus 2 plus 1. So 8 plus 2 is 10, plus 1 is 11. So 11 students scored greater than the mean, so 11. And we're asked what percentage of the class. Now there's 20 students in the class, so 11/20ths of the class scored greater than the mean. So 11/20ths of the class scored greater than the mean. Now we want to change this to a percentage, so let's change it to a fraction out of 100. So we want it to be a fraction out of 100 to change it to a percent nice and easily. So we're going to multiply both the denominator and numerator by 5 to get it to be out of 100. So times by 5 and times by 5. So 20 times 5 is 100, and 11 times 5 is 55. So we've got 55 out of 100, and that's 55%. So 55% of the class scored greater than the mean, and that's our answer, 55%. Okay, question number 11. So question number 11 says, Simon rolls a first 6-sided dice 30 times. So we know how many times he rolls it, 30 times. And he records the results in a table. However, he misses 2 of the frequencies. Simon. So we've got this table. We've got 6 number 1s, 3 number 2s, 5 number 3s. We don't know the frequency for the number 4s or 5s, and we know he gets 6 number 6s. But we're told the mean result is 3.5, and that's really useful because if we know what the mean is and we know how many times he rolled the dice, if we multiply those together, the 3.5 by the 30, that would give us the grand total. So in other words, whenever he adds up all the scores, what score that would be. So if we do 30 multiplied by 3.5, 30 times 3.5, that's equal to 105. So whenever Simon rolls the dice 30 times and he adds up all the scores, he would get 105. And then whenever he divides it by 30, he gets 3.5. So that means whenever he rolls the dice 30 times and add up all the scores, that's going to be equal to 105. And that's going to be the sum of the fx column, this column here that we're going to add on. So let's find what our fx column would be. So 1 times 6 is equal to 6. So 6 number 1s, if you add those up, so that would be 6. 3 times 2, if you rolled a 2 3 times, that would be 6. If you rolled a 3 5 times 3 is equal to 15. We've got this number and this number. Now, we don't know what they are. Let's call them x and y. They may not be the same as each other. That's why I'm going to call them different letters. So 4 times x is equal to 4x. 5 times y is equal to 5y. And finally, 6 times 6 is equal to 36. So we're going to add up our fx column. So let's add up this column and see what we get. Now remember, whenever we're collecting like terms, we can add x's to x's, y's to y's, and numbers to numbers. So here we're going to have 4x plus, and then we've just got 5y, and then we're going to add up our numbers and see what we get. So 6 plus 15 plus 36 is equal to 63. So whenever we add up our fx column, we get that's equal to 4x plus 5y plus 63. But we also know that's equal to 105 because we know that whenever we times the mean by the total frequency, we get the grand total. So that's equal to 105. So let's write that down. So 4x plus 5y plus 63 is equal to 105. And I'm just going to take 63 away from both sides of that equation. So minus 63 and minus 63 would give us 4x plus 5y is equal to, and 105 take away 63 is equal to 42. So that means that whenever we do 4 times x and 5 times y, when we add them together, we get that's equal to 42. Now, that's, at this point, we could try trial and error to try and find what the value of x and y may be. But it'd be useful if we had another equation, because then we could use simultaneous equations to find out what x and y are, because this looks like a bit like an equation you'd get in simultaneous equations. Now, if we go back up to our table, we were told that Simon rolled the dice 30 times. So that means if we add up the frequency column, that's going to be equal to 30. So let's add up the frequency column and see what we get. Now, remember, we can add x's to x's, y's to y's, and numbers to numbers. So if we add up this column, we're going to have x plus y plus, and whatever we get whenever we add up the numbers. So 6 plus 3 plus 5 plus 6 is equal to 20. So that means that the total frequency would be x plus y plus 20. But we know that that's equal to 30 because he rolls the dice 30 times. So let's write that as an equation. Let's write down x plus y plus 20 must be equal to 30. So if we take away 20 from both sides of this equation, so take away 20 and take away 20, we're left with x plus y is equal to 10, because 30 take away 20 is equal to 10. So now we've got two equations. We've got 4x plus 5y equals 42, and we've got x plus y is equal to 10. And they are simultaneous equations, and if we solve them, we can find x and y. So we've got our two simultaneous equations. I've numbered them, equation 1 and equation 2, and we want to cancel out either our x's or our y's. Now I'm going to cancel out our x's, so I'm going to multiply equation 2 by 4. I'm going to multiply equation 2 by 4 to get 4x's, so that we can take away the two equations to get the x's to cancel. So let's do 4 times equation 2 and see what we get. So 4 times equation 2 would be 4x plus 4y equals 40. So that's 4 times equation 2. I'm going to write equation 1 just above it, so 4x plus 5y equals 42. And if we take these equations away from each other, the x's will cancel. So let's subtract. 4x take away 4x, they cancel, that's 0. 5y take away 4y, that's just y. And then we've got 42 take away 40, that's going to be equal to 2. So y is equal to 2. So if we go back up here, we know that y is equal to 2. At this point, you could just look at the frequencies. You know that he rolls the dice 30 times, so we could add up these numbers and see what we get, and then take that away from 30 to see what x is. But also, we could go to our equations. We know that x plus y is equal to 10, equation 2. If we substitute y equals 2 into equation 2, we get x plus 2 is equal to 10. So that means that x equals 8. So that means that x equals 8. So we've got our value for x, which is 8, and we've got our value for y, which is 2. And that's it. So we found the value for x and we found the value for y. We found these missing frequencies. That number was 8 and that number was 2. Now this question was quite a tricky question. We had the mean from a frequency table. We had simultaneous equations. It was a particularly tricky one. If you can do questions 1 to 10 really well and confidently, fantastic. And this is just a bit of a challenge or an extension question in this particular booklet. Okay, question number 12 now. This is another extension question for this booklet. So if you can do questions 1 to 10, you're doing phenomenally well. So this question is that extension question, and we're going to have a look at it now. So the star rating from 1 to 5 stars of hotels in a city are summarized below. So there's hotels in a city. There's 4 hotels that have a 1-star rating, so you probably wouldn't want to stay in those. You've got 17 hotels that have a 2-star rating, 23 hotels that have a 3-star rating, X number of hotels that have a 4-star rating, and 18 hotels that are 5-star hotels. And then we're told the mean star rating of a hotel in the city is 3.575 stars. I've been asked to calculate the value of the missing frequency x. Now this question is quite tricky because we don't know the total frequency. If we knew the total frequency, it'd be quite easy actually. We could just add the frequencies, and take that away from the total frequency. But in this question, we're not going to be able to do that. But we are told what the mean is, and the mean is 3.575. So what I'm going to do is I'm going to try and work out the mean for what we've been given. And then, because we know what the answer is, 3.575, maybe then we can work out then what the x would be. So let's add on our fx column, and let's work out what our fx column would be by multiplying the star rating by the frequencies. 4 times 1 is equal to 4, 17 times 2 is equal to 34 stars, 23 times 3 is equal to 69, 4 times x is 4x, and 5 times 18 would be equal to 90. And if we add up the fx column, that will tell us what the total number of stars would be. Now remember, we can only add our x's to x's and numbers to numbers. So that'll be 4x plus, and then let's add up our numbers and see what we get. So 4 plus 34 plus 69 plus 90 is equal to 197 stars. plus our 4x. So our total fx is 4x plus 197. Now let's add up our total frequency. So because remember to find the mean, we divide the total fx by the total frequency. So if we add up our frequencies, adding our x's to our x's, that's going to be x plus, and then adding our numbers, 4 plus 17 plus 23 plus 18 is equal to 62. So it's going to be x plus 62. So we've got our total fx and we've got our total frequency. Now we would normally divide this by this to find the mean. So let's do that and let's see what we get. So let's do 4x plus 197 divided by x plus 62. And that's equal to 3.575. Okay, so we've got our equation. We just need to solve it now. Now, when I say just, it's not a particularly nice equation, so it is a bit tricky. So let's see how you would solve something like this. So we've got 4x plus 197 divided by x plus 62 equals 3.575. Now, I don't like having x's on the denominator. I try to get rid of them on the denominator if I can. So we've got 4x plus 197 divided by x plus 62. So I'm going to multiply both sides of this equation by x plus 62. Now I'm putting it in a bracket because I'm multiplying by x plus 62, and I'm just making sure I'm not going to multiply just by x or by 62. Well, I'm multiplying by x plus 62 to get rid of the divide by x plus 62, so I'm just going to be left with 4x plus 197. And then on the right hand side of the equation, I've got this number and I'm multiplying it by x plus 62. Well, I'm just going to write the number in front of the bracket x plus 62, because I'm multiplying 3.575 by x plus 62. So I'm going to multiply what's inside the brackets by 3.575. So 3.575 times x would be 3.575x, then plus, and then I'm going to multiply 62 by 3.575, and that's equal to 221.65. Now I've got an equation with x's on both sides and numbers on both sides, so I'm just going to solve this equation now. So this is like solving an equation with x's or letters on both sides. So I tend to like to get rid of the lowest number of x's if I can. So I've got 4 x's and 3.575 x's. So I'm going to minus the lower number, the 3.575 x's, from both sides of this equation. So minus 3.575x from both sides of this equation. So 4x, so 4 minus 3.575 equals 0.425x. The numbers are going to stay the same, so plus 197 equals. Now I'm taking away 3.575x to get rid of the 3.575x, so that's going to leave me with 221.65. Now I want to solve this equation, so I want to get rid of the plus 197. So I'm going to minus 197 and minus 197 because I want x's on one side and numbers on the other. So my left hand side here would just become 0.425x, and on the right hand side we're going to do 221.65 take away 197 equals 24.65. So we're nearly there. We've got 0.425 times x equals 24.65. So if we divide both sides of this equation by 0.425, so divide by 0.425 and divide by 0.425, we should find x. So our left hand side, we're dividing by 0.425 to get rid of the times by 0.425, so I'll just leave us with x. And on the right hand side, now whenever we divide this, we're finding x, which is a frequency, so hopefully this will be a whole number. If this is a whole number, we could be correct. So 24.65 divided by 0.425 equals 58, and that's fantastic. So that is a whole number, and if we go back up to our table, that means it should be 58 hotels with a 4-star rating. Now we could check our answer and see if we get a mean of 3.575, but I'm pretty confident we've got that right, so our answer is 58. And that's it. Now, the question was a bit of a challenge question. If you can do questions 1 to 10 really well and confidently, well done. I think that's fantastic work. If you can do question 11 and question 12, you're doing absolutely phenomenally. You're doing really, really well. Well done. So these have been the video solutions to the mean from a frequency table practice questions. If you need any extra help on the mean from a frequency table, watch video 54 on Corbettmaths. But that's it. So I really hope you found this video useful. If you have liked it and if you have found it useful, please like the video and please subscribe to the YouTube channel. Thank you. Cheers. Bye.